Good morning, everyone. Today we're going to be taking a look at Chapter 4, Section 2, which is all about experiments. More specifically, this is about experimental design. How does one design an experiment? On the AP test, you will be expected to provide details on what needs to be done in order to have a well-designed experiment. It's actually pretty well regimented about what kinds of experiments that you're going to be designing in AP Statistics. By my count, there's only 3 design types that ever really show up, and with a couple of different looks to them, of course. So as we get started on this, we're going to keep that in mind. Experimental design, what kind of experiments are we looking at, and what kind of experiments will be expected of us? To get us started, we're going to have this worksheet here with day 1, and this is going to be an experiment involving SAT scores and SAT prep classes. So last year, it says EKHS was offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was 1,220. And then the average SAT score for all students who did not take the prep class was 1050. So the conclusion that the class will raise SAT scores definitely has some evidence to it. We don't know if it's a convincing evidence yet, but there is evidence that the students who take the course will have a higher average, just because the average from the SAT group, or the SAT scores from the prep group, is greater than the SAT scores from the non-prep group. However, that in itself may not be enough to conclude that the prep class is cause to a higher SAT score. Question 1 here says, is a design described an observational study or an experiment? Well, no one is being forced to take the course, or I should say, students were not assigned to their treatments. So if the experimental units are not assigned to their treatments, then this is not an experiment. So we can say that this is an observational study. It could be a really good observational study, but it's still not an experiment. Question 2 here. Can we identify the explanatory and response variables? I like to think of this as a very exact thing, and I also like to start with a response variable. For me, that's easier. So response variable is, in my head, I think it's what are we actually measuring? What are we assigning a number to, or what numbers are we taking? The numbers that we're taking here are going to be SAT scores. So that seems like our response variable would be SAT scores. And once we have SAT scores as our response variable, then it's pretty clear that the thing that we're trying to show is the cause for the SAT score increases is going to be the course that they took. Whether or not they took the course will be our explanatory variable. Once we have our explanatory variable and our response variable in place, it's pretty easy to go from, well, our explanatory variable is going to inform our choice of treatments. So a treatment here is going to be the entire combination of factors that will be assigned to the treatment groups. So we have one explanatory variable with two levels. The explanatory variable is taking the SAT course. The levels are yes, they took the SAT course. No, they did not take the SAT course. And then again, those outcomes are the SAT score. Moving on, question 3. Can you conclude that taking the prep course will cause a student's SAT score to increase? Now, it may not seem like it, but that's very strong wording. The wording here will cause an SAT score to increase. That's a cause and effect relationship. That means that under every case or almost every case, if a student takes the SAT class, their SAT score will go up. So that may or may not be the case, but and the reason why is maybe this is just a correlation. Perhaps the students who are highly motivated are going to take the course and they would have scored higher anyways. Again, there is a correlation between taking the course and higher SAT scores, but that doesn't mean that it is a cause and effect relationship. In order to show cause and effect relationships, we need to have an experiment. I think that's enough said about that. This brings to mind that we have a bunch of memes about correlation and causation. Here we have one where we have dry, hot, sunny weather, sunny summer weather, and well, usually that means that the ice cream sales are going to go up. Also, the dry, hot, sunny weather is going to cause a lot of sunburns. So in other words, when the ice cream sales increase, sunburns also increase because they are both directly caused by the sunny weather. So there is a correlation that exists between high ice cream sales and sunburn. We would never say that ice cream sales cause a sunburn, but there is some kind of a correlation there. So again, the correlation is not causation. Item 2. Nicolas Cage movies and swimming pool drownings. We notice that if there are a large number of Nicolas Cage movies shown in this black line, then there is also an increase of swimming pool drownings. So here again, both of these have a common cause, but they are not a causation between each other. So if we could think about this, Nicolas Cage movies tend to be released during the summertime. Swimming pool drownings will often there'll be more of them during the summertime as well. So we can see, or we can at least imply, that both of these have a common cause in the number of films in the summer or with summertime weather. Here's another one. This is kind of fun. Correlation and causation. We've got the guy up here on the flatbed truck. He's pushing the front of the truck. He's not really doing anything, and the people in the back here are pushing the back of the truck. They're actually causing the truck to move. Just because there is a correlation between the guy on the flatbed pushing the car and the car moving forward doesn't mean he's causing the car to move forward. And then finally, as a funny one, we have this one here. I used to think that correlation implied causation. Then I took a statistics class, and now I don't. So it looks like the class helped. Well, maybe. I'll leave you to decide where the correlation and the causation for this one is. So there is a correlation between taking the class and high scores, but that doesn't mean that taking the class necessarily means high scores on the SAT. Moving on. Identify as many other possible variables that can explain why the SAT scores are higher for people who took the prep class than for students who did not take the prep class. Well, here are a few. Perhaps all the students who decide electively to take the SAT prep class, they're all trying to get in college. So they have a vested interest or maybe a higher interest in taking that SAT, in getting higher scores. Also, if they are taking that prep class, there's probably less of them would have an after-school job or extracurricular activities because that would interfere directly with taking that class. Another thing would be they all have rides home from school. I'm not 100% sure about this one. I think we're trying to say something about they all get a ride home from school, so maybe they all come from a higher socioeconomical background. So we have shown that there is a high correlation between socioeconomical backgrounds and higher SAT scores. And maybe they all just want to do well on the SAT, and that can't be said with as much certainty for the students who did not take the SAT prep class. So there's a number of reasons why higher scores are correlated with students who take that prep class. All of these things that are related to the response variable but are not actually part of the study, we call these confounding variables. And I think that in a lot of students' heads, they think confounding variable means they're bad. That's not necessarily true. It's more like they exist. And because they exist, we have to keep them in mind as we do our experiments, and definitely as we look at the results of our experiments and try to analyze what happened. Confounding variables exist for basically every experiment or every observational study. To be clear, a confounding variable is a variable that affects the response variable. So students trying to get into college, that is a confounding variable because that will affect SAT scores. Is that one of the treatments, or is that included in the treatment? No, it's not included in the treatment. So we would say that trying to get into college is going to confound with the SAT class. Having after-school jobs, is that going to affect scores on the SAT? Well, you might think differently from your anecdotal difference, but if you look at the numbers, yes, there is a correlation there between having an after-school job and scoring well on the SAT. Having a ride home from school, again, your experience may be different. However, we can show that there is a high correlation between having a ride home from school and having high scores on the SAT. So all of these confounding variables, we need to talk about them. We need to do something about confounding variables. Otherwise, we'll never be able to show a cause and effect relationship in our experiments. Not that this was an experiment to begin with. Our SAT class was always just an observational study. We were never going to be able to show cause and effect, but these are things to keep in mind as we start to create our experiments. Here's the part where you will see a question like this on the AP test or even on your test at school. Design an experiment that would allow us to determine if SAT prep causes an increase in SAT score. Be as thorough as possible. Okay, so here's what we're going to do. We're going to randomly choose 100 juniors to take part in the experiment. We're going to randomly, again, split the juniors in half. So half of that is going to take the SAT prep class, and the other half is not. In other words, 50 of the juniors are going to take the prep class, 50 are not. Now, the reason why this is good is because that using the randomization, it's going to be likely that some of the juniors in the treatment group 1 will, for example, be trying to get into college. Also, we'll have some of those juniors in treatment group 2 who are trying to get in college. So that equalizes that confounding variable among the two groups. It doesn't eliminate the confounding variable. It just makes two groups as even as possible in relation to that one confounding variable. Same thing for after-school jobs or extracurricular activities. The randomization process is going to do a good job of making sure that treatment group 1 is going to have students that have after-school jobs, and treatment group 2 will also have students who do have after-school jobs. Same with all of these other confounding variables. If we wanted to do something more directly about them rather than randomization, then that would be a different design. We'll definitely talk about that kind of design in future classes. So after that course is over and we've allowed randomization to evenly split confounding variables between the two groups, all of the 100 juniors are going to take the SAT. When that's done, we're going to compare average scores from each of the groups. And presumably, if the average score from the SAT group is higher than the SAT prep group is higher than the average score from the non-SAT prep group, then we can have good evidence for a cause and effect relationship. The 100 juniors in our experiment, those are the experimental units. Because they're human beings, we can also call those experimental units subjects, but either one of those vocabulary words apply when we have a human experimental unit. Notice that we had half the juniors take the class and the other half did not. This corresponds directly with what we were saying, where we had one explanatory variable in two different levels. In the two different level, therefore, we have two treatments. The treatments then are going to be half the juniors will take the class, or treatment 1 will be taking the class, treatment 2 will be not taking the class. And then the average scores is going to be the response variable for this experiment. And that is our class. We have big ideas here. Big ideas number 1. Observational studies means that no treatments are imposed. We're only going to observe. I like the word imposed because that implies, or that says that we're telling our subjects, we're telling our experimental units what to do. In an experiment, treatments are imposed. And for a good experiment, we're always going to have more than one treatment group. Explanatory variables are the things that we use to predict. If there's more than one explanatory variable, we're going to call them factors. And of course, the factors can have two levels. We were looking at this one just now, and our factor of the SAT prep class, that came at two levels. SAT prep class, yes. SAT prep class, no. Treatment is what's done to the participants or the experimental units. It's in a combination of factors. Experimental units are who was the treatment imposed upon. Human experimental units are often called, and I don't know why that didn't show up there, but they're called subjects. And finally, we have confounding variables. Confounding variables are variables that are not controlled. In other words, we didn't do anything about them in the experiment, and they're going to affect the response variable. This little diagram over here with A and B and the response, that just means that explanatory variable A is going to affect the response. Explanatory B is going to also affect the response. Therefore, variables A and B are confounding because they both affect the response. All right. Now that we have that, let's go to check your understanding. Does reducing screen brightness increase battery life in a laptop computer? To find out, researchers obtained 30 new laptops of the same brand. That's an instance of control. We have the same brand. 30 laptops, that's an instance of something called replication. We have many experimental units. And they choose 15 of those computers at random and adjusted their screens to the brightest. The other 15 were left at the default setting, which is moderate brightness. That's our 2 treatments. Researchers are then measured how long each machine's battery lasted. And the question is, was this an observational study or an experiment? So our question is, did we create treatment groups? Did we impose a treatment? Yes, we did. We absolutely had 15 computers at the highest brightness level. We had 15 at the default setting. So because we were imposing these treatments, this is going to be an experiment. Okay. Questions 2 through 4 refer to the following setting. Does eating dinner with their families improve a student's academic performance? According to an ABC News article, teenagers who eat with their family at least 5 times a week are more likely to get better grades at school. This finding was based on a sample survey conducted by researchers at Columbia University. Okay, so was this an observational study or an experiment? Let's try to dissect this a little bit. What are we measuring here? We're measuring grades. So grades are the response variable. Okay, who is getting the treatment here? And it looks like the teenagers are the ones who are split into groups, I should say, although not really split into groups because reasons we'll talk about later. How about treatments? Okay, I can see 2 treatments that are implied from this article. Treatment 1 would be teenagers are eating at least 5 times a week with their family, and the other treatment would be not eating at least 5 times a week, or eating 4 or less times a week with their family. Okay, and then our experimental units, our subjects are those teenagers. Are we imposing a treatment? Are we telling the teenagers to eat with their family 5 times a week? Are we telling other teenagers not to eat at their families 5 times a week? And I don't think they did. This was based on a survey. That's another clue. So this looks like it's going to be an observational study. We didn't assign students to eat with their families or not eat with their families. So observational study, no treatment was imposed. Okay, how about what are the explanatory and response variables? We kind of talked about this. With the treatments, that implies that the explanatory variable is going to be eating with your family, and the response variable here is going to be the grades. Remember that explanatory variable is different than a treatment. A treatment is a specific combination of factors that are imposed upon our experimental units. And lastly here, explain clearly why such a study cannot establish a cause and effect relationship. Suggest a variable that might be confounding whether families eat together. It's pretty clear that we're not going to be able to establish cause and effect relationship because this wasn't an experiment. But what could be confounding whether families eat together? Are there other things that were not in this study that also affect grades? Well, looking at this from like a social justice point of view, we could always say that, maybe not always say, but there is a high correlation here between socioeconomic status and grades. There's also a high correlation between socioeconomic status and whether families eat together. So that looks like a confounding variable. A couple of other ones over here that we have are, what is this? Teens who eat with their families may have something in common that affects their grades. Healthy diet could affect grades for sure. Family support, yes. I'm sure there's a correlation between family support and eating as a family or eating together as a family. I was thinking about this just now, and there's also parents who have multiple jobs will probably not be able to eat with their family. And I think there is a correlation between parents with multiple jobs and grades at school. So there is definitely at least a few things that we can correlate with grades that will confound the results of this study. Not to say it's a bad study, just to say that we can't establish a cause and effect relationship. So that's the end of our work here today. We'll see you all for the next one, where we take a look more at designing experiments.